All right. Well, thanks, guys, for having me. Hopefully, I can get through this in 15 minutes, and then we can have a really great discussion afterwards. So just to kind of go over the title again, Enhancing the Chesapeake Bay Report Card with New Indicators and New Methods. And this is a whole big project with a lot of different people, but my co-authors are Bill Dennison, Heath Kelsey, and Alex Fries. So some of the background about how we're enhancing and changing the report card. One of the things is new indicators, so adding total nitrogen, total phosphorus, but also talking about the loss of the phytoplankton IBI. Then I'm going to talk about multiple thresholds versus the pass-fail thresholds, and how we did some analysis on both those ways. I'm going to show you the new 2012 grades using the new indicators, and also how we're moving towards trajectories or looking at trends analysis, so looking at trend analysis over the entire period of record, and showing those in the report card. And also talking about a flow adjustment analysis that we did. This was something that we've gotten criticized on a lot, in a good way, constructive criticism. Why is it that the bay health always follows the weather? So we always talk about how it ends up being a weather story. If it rains a lot one year, the grade goes down. If it's a dry year, the grade goes up. And how can we adjust for that using maybe trying to take the flow out of the variability? Also, I'm going to talk about fisheries indicators. That's another thing that we've gotten some suggestions about how to incorporate fisheries indicators into the report card. This is just a picture of how we did this process. Is we contacted a lot of academic experts. We wanted to make sure that it was scientifically rigorous and kind of outside the agency realm to try to get some new perspective. And we got together a whole bunch of water quality experts and a whole bunch of fisheries experts at different workshops throughout the last 6 months. So one of the things that we struggled with last year and again this year is the phytoplankton IBI data. It did come through in 2011, but in 2012 we didn't have the Maryland phytoplankton IBI. This kind of was like a launching point for us to kind of look at the indicators again, take a step back, and see what was missing and what we needed. And so we actually incorporated total nitrogen and total phosphorus. And obviously the phytoplankton IBI is not there. And one of the things that this does is make it match up a lot with our tributary report cards. So our tributary report cards don't include phytoplankton IBI, but instead have TNTP, the chlorophyll A, dissolved oxygen, water clarity as the 5 water quality indicators. They're easy to measure, and a lot of the groups are already measuring that. And so in this way, the Chesapeake Bay report card would be more similar to the tributary report cards. It's all the same. I want to mention that the TNTP data is from the Bay Program water quality station sites out of the database. And when we looked at these indicators, that's when we started also thinking, well, maybe we should look at doing multiple thresholds. Multiple thresholds take instead of a pass-fail where you have one number, like DO 5 milligrams per liter, instead it assigns a value 0 to 5 based on different thresholds throughout the, for chlorophyll, for dissolved oxygen, for water clarity. And so we did a complete analysis of using the MTAC protocol multiple thresholds on all the indicators, and looked at how we could use that. What happened was that, looking at this graph right here, you can see the multiple thresholds analysis for water clarity versus the pass-fail thresholds, the one that has been in the report card all these years. And you can see it basically the scores jump significantly, because if you're just below that pass-fail, you get an automatic 0, whereas in the multiple thresholds, you would probably get a 3 out of the 0 to 5 range, because that 4, we set the 4 value as the ecological threshold. But I think communicating this was a difficult process. So one of the things we always get is how do we do this year compared to last year? And we're just not, it's not comparable. We have new indicators, and then if we did the multiple thresholds, it would be significantly different. It'd be a whole different story. So we decided to stick with the pass-fail thresholds that we've always used. We're already going to be pretty different in the report card, and we didn't really want to make that leap to the multiple thresholds analysis. So here is some of the overall results. Again, the new indicators, dissolved oxygen, chlorophyll A, water clarity have always been there, TN, TP. We're going to keep including the benthic, IBI, and aquatic grasses, but we won't have any sub-indices. All of these indicators are equally averaged into the overall Bay Health Index. You can see the variability in the scores. This provides an overall grade of a C. This actually matches pretty well with what we've been seeing in the last 6 years, but we did do an overall analysis as well, which I'll get to next. And this is just the usual Bay-wide map that we show with the different reporting regions. So the different reporting regions, surprisingly, some things did change, like the lower Bay got a B-. I don't think we've ever had such a high grade down there. And then typically the Patapsco Back River and the lower Western Shore of Maryland typically gets the worst scores, which is also occurring at this time. So this is a new analysis that we're also doing. So we took all the new indicators and we back calculated the scores to the 1986, time frame, and so we could look at the trends analysis using these new scores. So you would have the Bay Health Index for the Patapsco River calculated using all the new indicators from the 80s to the current year. And then what we did on that is obviously do a linear regression and use statistical analysis to come up with p-values. What we did with the significance is described the trend, saying that, well, if the p-value is less than 0.05, you would get a significantly positive trend or a significantly negative. Obviously, the slope of the line is negative or positive, not the p-value. And then I don't know if you can see my arrow. There we go. So significantly positive 0.05, slightly positive 0.1, and then no trend if it's greater than 0.1 in the p-values. And so you can see here the trends showing slightly different. You would have a grade is C, but there's no trend going up and down, versus the good news with the Elizabeth River, it got a D, but it's trending, it's getting better. So here's the map of the same thing. And so what we did was the same type of grades map, but with the trajectories. And what you can see is the upper Bay and the upper Western Shore are significantly improving, as is the James, versus something like the Mid-Bay, which is the one that's significantly decreasing. And I think this is really cool results about how we're looking at these scores now and seeing whether that has, if the Mid-Bay is doing poorly one year or the next, that's really good to know. But also, is it getting worse or is it improving? This can help us target where we need to do restoration. So we did these trends analysis on the linear trends. So we did not use any kind of polynomial trend. So the next step is, and we've been talking to Elgin Perry about this, is using a generalized additive model to actually look at maybe there might be some breakpoints in the time period. Joel Bloomquist has presented some really good talks about how they've been looking at nutrient trends and looking at different time periods. And so this is just an example of the upper Western Shore, and it, over the time frame. So the upper Western Shore is here. It's getting significantly positive over the linear trend. However, in the last few years, it's actually been decreasing. So if you overlaid a linear trend on this, it would go up. But we're actually seeing like a pretty significant break point around 2004. And so we're going to do this for every single reporting region and look at these GAM analyses in the future. Fisheries indicators. So that was all in the report card. That's part of the Bay Health Index. A separate thing we're doing, which is not going to be part of the overall Bay Health Index, are fisheries indicators. We worked with a bunch of fisheries guys around the Bay. This is Bay-wide information. It's just, there's no way that we can do reporting region level fisheries for all the reporting regions. We also, communication-wise and just analysis-wise, it's a little more complicated. For striped bass, a 3-year average is being used, and you compare it to the long-term mean. So these aren't ecological thresholds in the sense that you need a certain amount or not. It's about number of fish. For blue crab is great because it's on an annual scale, just like the Bay Health Index is, and there's already targets for it. So we're using the Maryland DNR target for adult female blue crabs. That indicator seems to be the most straightforward. And then Bay anchovy was also suggested, and we're using, again, kind of like the striped bass, but the geometric mean compared to the long-term average. And we're only presenting it in this graph. We're not going to give them grades or anything like that, but what you can see is that the blue crab went up and it came back down. I actually think 2013 data is already available, so that should tick back up next year. Striped bass kind of goes up and comes back down, but very variable. And then Bay anchovy is a pretty good indicator and seems to be much more reliable. So that stuff is all the some of the new analysis that we've been doing. And for the rest of the talk, I'm going to go over our flow adjustment analysis. What we did was we took, again, bay-wide. We had to use bay-wide flow. There's not enough flow data for each of the reporting regions. Like, we could look at the Chop Tank or we could look at the Potomac, for instance, but we can't do that for each reporting region. So we looked at flow-adjusted indicators at a bay-wide scale. The indicators that are related to flow include dissolved oxygen, chlorophyll A, water clarity, and total nitrogen. Total phosphorus was not related to flow, so we did not do a flow adjustment on that. We also looked at the overall Bay Health Index as well. So flow adjusted scores are analyzed at the overall bay level. We don't want to confuse the report card by including flow adjusted and non-flow adjusted trajectories and grades on the printed report card. So the entire flow adjusted analysis will be on the website. So we found that Bay Health Index is related to river flow. About 40 to 50% of the variability is explained by flow. So here's that graph that you can see here. This is just the basic plot out the flow compared to the BHI over time. Then you take the residuals and you look at this variability between the linear regression line and the data. That's the residuals is what they're called. So you plot out those residuals along the zero axis. Excuse me. So the results are shown here. This is the overall Bay Health Index. The original score is in red, and then the residuals, or what you would see if you take out the variability and flow, is in black. And what I think you can see is that huge score that we had in 2002, before the wet year of 2003, and then in 2003 it really went down low. Well, if you take out that variability and flow, you actually don't see nearly as many peaks and valleys. Interestingly enough, especially for 2012, it's going back up, and I think the trend around the last few years, I know it's only a few years, but I think we saw such huge variability, whereas really it's kind of flat. These results are the indicators individually. So dissolved oxygen follows it pretty well. Taking out the flow doesn't really show that much. Chlorophyll A responds in the same in those peaks, takes out those peaks. Water clarity, I think, responds really well to flow, and so I think these results will really be interesting when you look at water clarity and obviously total nitrogen. And you can see this like nice increasing trend in total nitrogen, and that's what we've been finding in a lot of other studies too, about how the nitrogen is getting better in the bay, and we're also seeing that in our scoring system, which was nice to see for us this year. So in conclusion, we think a lot of these new analyses provide a more robust view of health, including the indicators and incorporating fisheries. You know, it has been something that people have been requesting of us for a while, and I'm glad we got around to it. I know we can't do it at the reporting region level, but you know, at least we can say something about fisheries in the bay as a whole. And the trajectories are really interesting and a way forward to kind of combine annual grades with an overall improving or worsening trend. So thank you very much.